Alright, so in this video, I'm going to solve the equation 3 to the power of x is equal to 15. So my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. So let me first start by rewriting my equation down here. So 3 to the power of x is equal to 15. And 15, I can rewrite this as 3 times 5. And now I'm going to take the log on both sides. So I get log of 3 to the power of x is equal to log of 3 times 5. And if I have something in the form log a times b, this is equal to log a plus log b. So log of 3 to the power of x, this is equal to log of 3 plus log 5. And if I have something in the form log a to the power of b, I can move b to the front, so I get b times log a. So log 3 to the power of x, I can move this to the front, and I get x times log 3 is equal to log 3 plus log 5. So now from here, I'm going to divide both sides by log 3. So for my left-hand side, these two cancel out, and for my right-hand side, I get x is equal to log 3 plus log 5 over log 3. And this is the same thing as log 3 over log 3 plus log 5 over log 3. So log 3 and log 3, these two cancel out, so I get x is equal to 1 plus log 5 over log 3. Now, log 5 is equal to 0.6990, and log 3 is equal to 0.4771. So this is going to equal 1 plus 0.6990 over 0.4771. Now, 0.6990 over 0.4771 is equal to 1.4851, and 1 plus 1.4851 is equal to 2.4851. So this is my value of x. Now make sure to subscribe and leave a like, and thank you. Bye. Alright, so in this equation, I have 1 to the power of x is equal to 3. So this might seem like an impossible equation, right? Because how can 1 be to the power of any number and equal to 3 if 1 to the power of even a million is still equal to 1? Well, let's try to solve this equation the way we would solve any other exponential equation. The first thing I would do is take the natural log, or ln, on both sides. So I get ln 1 to the power of x is equal to ln 3. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this is going to equal b times ln a. In this case, I have ln 1 to the power of x, and I can move x to the front. So now I get x times ln 1 is equal to ln 3. And now if I divide both sides by ln 1, these two cancel out, and I get x is equal to ln 3 over ln 1. Now, if you guys already didn't know, ln 1 is equal to 0. So I get x is equal to ln 3 over 0, and you can't take any number and divide it by 0 because that's undefined, meaning this has no solution. So that method doesn't work. However, this just means that there are no real solutions. But there are different types of solutions. So what I'm going to do to solve this equation is, first, let's recall Euler's formula. And if you guys don't know what this is, it states that if I have something in the form e to the power of I times theta, this is equal to cos of theta plus I times sine of theta. And I know this may seem a little complicated right now, but just bear with me. So let's say that theta here is equal to 0. So if theta equals 0, then I get e to the power of I times 0 is equal to cos of 0 plus I times sine of 0. So then I get e to the power of 0 is equal to 1, cos of 0 is 1, plus sine of 0 is 0, and 0 times I is 0, so 1 plus 0. And e to the power of 0 is 1, so I get 1 is equal to 1 plus 0. Now, what if we say that theta is equal to 2k pi? K being a constant, so it could equal any number, 1, 2, or 3. So if I plug this in, I get e to the power of I times 2k pi is equal to cos of 2k pi plus I times sine of 2k pi. Now, what if k is equal to 1? What if our constant k is equal to 1? Then I get e to the power of I times 2 pi is equal to cosine of 2 pi plus I times sine of 2 pi. Now, cosine of 2 pi is 1, and sine of 2 pi is 0. So I get this is equal to 1. Now, if k is equal to 2, I would get cos of 4 pi plus I of sine 4 pi. Cos of 4 pi is 1, and I times sine of 4 pi is again 0. And if I do the same thing with 3, I would again get 1 plus 0. So this pattern continues, and it keeps on equaling 1 no matter what value of k we get. So we can say that e to the power of I times 2k pi, this is equal to 1 no matter what value of k we have. So now this means that we can substitute this in back to our original equation, which is 1 to the power of x is equal to 3. This is our original equation, and we can substitute in 1 for e to the power of I times 2k pi. So now I get e to the power of I times 2k pi to the power of x is equal to 3, and this is my new equation. So now, to solve this, I'm going to do what I did at the start. I'm going to take the natural log or ln on both sides. So I get ln e to the power of I times 2k pi to the power of x is equal to ln of 3. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so I get b times ln a. In this case, I can move x to the front, so I get x times ln e to the power of I times 2k pi is equal to ln 3. Now I'm going to use this property again and move this to the front as well. So I get I times 2k pi times ln e is equal to ln 3. And ln e, these two cancel out. So now I'm left with I times 2k pi is equal to ln 3. Sorry, and I also have x. Now I'm going to divide both sides by I times 2k pi. So when these cancel out, and I get x is equal to ln 3 over I times 2k pi. Now I'm going to multiply this by I over I, which is the same thing as 1. So I get x is equal to I times ln 3 over I times I squared, and if you guys already know, I squared is equal to negative 1, so over negative 2k pi. And k, in this case, can't equal 0, because if k over 0, this wouldn't work. So this is my solution to this equation. Alright, so for this video, I'm going to be solving the equation 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. So I'm going to be solving for x in this equation, as that is the only variable. And now for my solution. I'm going to start by rewriting my equation down here so I have more solving space. So my equation is 8 to the power of x plus 9 is equal to 9 to the power of x plus 8. Now from here, I'm going to be using the property of exponents that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 8 to the power of x plus 9, and I can rewrite this as 8 to the power of x times 8 to the power of 9. And this is equal to 9 to the power of x plus 8, which I can also rewrite as 9 to the power of x times 9 to the power of 8. Now from here, I'm going to divide both sides by 9 to the power of x. So then for my right hand side, these two cancel out, and I get 8 to the power of x times 8 to the power of 9 over 9 to the power of x is equal to 9 to the power of 8. Now I'm going to divide both sides by 8 to the power of 9. So then these two cancel out, and I get 8 to the power of x over 9 to the power of x is equal to 9 to the power of 8 over 8 to the power of 9. Now, from here, I'm going to take the log on both sides. So I get log of 8 to the power of x over 9 to the power of x is equal to log of 9 to the power of 8 over 8 to the power of 9. Now, if I have something in the form log a over b, this is equal to log a minus log b. So log a to the power of x over 9 to the power of x is going to equal log of a to the power of x minus log of 9 to the power of x. and I can use the same property of log 9 to the power of 8 over 8 to the power of 9 to make it equal to log 9 to the power of 8 minus log 8 to the power of 9. Now, another property of logarithms is that if I have something in the form log a to the power of b, I can move this exponent b to the front. So this is the same thing as b times log a. In this case, I can use this property for all my terms over here. So to start, log 8 to the power of x, I can move this to the front, and I get x times log 8. Now I have this minus log 9 to the power of x, I can move x to the front, so I get x times log 9. And this is equal to log 9 to the power of 8. I can move 8 to the front, so I get 8 times log 9 minus log 8 to the power of 9. I can move 9 to the front, so I get 9 times log 8. Now, because both of these terms have x in them, I can simply factor out x. So I get x times log 8 minus log 9 is equal to 8 times log 9 minus 9 times log 8. Now, we obviously want to find the value of x, and the only way to do that is to get rid of this log 8 minus log 9 by dividing both sides by log 8 minus log 9. So then these two cancel out, and I get x is equal to 8 times log 9 minus 9 times log 8 over log 8 minus log 9. Now, log of 9, we can simplify this to log of 3 squared. And remember, if I have something in the form log a to the power of b, I can move b to the front. So I can move 2 to the front, and this is going to equal 2 times log 3. Now I can do the same thing for log 8. Log 8 is equal to log of 2 to the power of 3, and I can move 3 to the front, so I get this equal to 3 times log 2. So now from here, I get x is equal to 8 times 2 log 3 minus 9 times 3 log 2, and I have this all over 3 log 2 minus 2 log 3. Now 8 times 2 is 16, so I get x equals 16 times log 3 minus 27 times log 2 over 3 log 2 minus 2 log 3. And all of this is equal to 9.6548. Alright, so in this video, I'm going to be solving the equation 25 to the power of x minus 5 to the power of x is equal to 20. So to solve this equation, I'm going to first start by subtracting 20 on both sides. So then these two cancel out, and I get 25 to the power of x minus 5 to the power of x minus 20 is equal to 0. Now 25 to the power of x, I can rewrite this as 5 squared to the power of x. So I have this minus 5 to the power of x minus 20 is equal to 0. And now from here, if I have something in the form a to the power of m to the power of n, This is the same thing as a to the power of m times n. And a to the power of m times n I can rewrite as a to the power of n times m. So if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m should equal a to the power of n to the power of m. So phi to the power of 2 to the power of x is going to equal phi to the power of x to the power of 2. Now I have this minus phi to the power of x minus 20 is equal to 0. And now I'm going to let phi to the power of x is equal to y, so I get y squared minus y minus 20 is equal to 0. Now, to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 20. So I get y equals negative 1 plus or minus the square root of b squared, so negative 1 squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 20, all over 2a, so 2 times 1. And this is equal to 1 plus or minus the square root of 1 plus 80 over 2, which is equal to 1 plus or minus the square root of 81 over 2. And the square root of 81 is equal to 9. So I get y is equal to 1 plus or minus 9 over 2. Now this gives me two solutions. I get y equals 1 plus 9 over 2, and y equals 1 minus 9 over 2. So 1 plus 9 is 10, and 10 divided by 2 is 5, so I get y equals 5 as one solution, and 1 minus 9 is negative 8. Negative 8 over 2 is negative 4, so y equals negative 4 is another solution. Now from here, remember how we let 5 to the power of x equal to y. So this means I get two solutions. Phi to the power of x is equal to 5, and phi to the power of x is equal to negative 4. So let's look at this equation over here. Phi to the power of x equals negative 4. Well, we can't take the power of a positive number and turn it into a negative number, meaning this equation has no solution. And for phi to the power of x equals 5, to solve this, what most people do is, for other exponential equations, we would have to take the log and do a bunch of other stuff. But as over here, we could just see 5 to the power of 1 is going to equal 5, because anything to the power of 1 is itself. So this is my solution.